Hello friends, welcome to this session. Today we are studying variation of mass with velocity, that is relativity of mass. Let us consider two frame of references, that is S and S dash. S dash is moving with constant velocity v relative to S along the positive x direction. The frame is at rest. Frame S is at rest. Let us suppose that in the system S dash, two exactly similar elastic balls A and B approaches each other at equal speeds, that is u and minus u. Let the mass of each ball be m in frame S dash. They collide with each other and after collision coalesce into one body. According to the conservation of momentum of law, momentum of a ball A plus momentum of a ball B is equal to momentum of coalescent mass. So that is mu plus of minus mu is equal to momentum of coalescent mass. And the momentum of coalescent mass is 0. That is, the coalescent mass be at rest in the frame S dash. Now let us consider the collision with reference to the frame S. Let u1 and u2 be the two velocities of the balls, and that is relative to S. So u1 is equal to u plus v divided by 1 plus uv by c square. Similarly, for u2, the negative sign is there, minus u plus v divided by 1 minus uv by c square. After collision, the velocity of the coalescent mass is v relative to the frame S. Let the mass of the ball A traveling with velocity u1 with bm1 and that of the B with velocity u2 bm2 in the frame S. So the total momentum of the balls is conserved. Therefore, you can write m1 u1 plus m2 u2 is equal to m1 plus m2 into v. Putting the values of u1 and u2 from the equation 1 and 2 in the equation number 3, that is m1 in bracket u plus v divided by 1 plus uv by c square bracket close plus m2 minus u plus v divided by 1 minus uv by c square, that equals to m1v plus m2v. After rearrangement, we get the mass of bodies, that is m1 is equal to m2. So the equation becomes m1 in bracket u plus v divided by 1 plus uv by c square minus v is equal to m2 into v minus u plus v by 1 minus uv by c square. After solving this, we get this equation. Then just rearrange it. So minus v, plus v and minus v get cancelled here, and here plus or v get cancelled. So we get u minus uv by c square this side, and this side u minus uv square by c square. At the denominator side, there 1 plus uv by c square, here 1 minus uv by c square. Then just simplify it. I am taking the u outside the bracket, so it gives the 1 minus v square by c square, here 1 minus v square by c square. Then we get After solving this equation, we get m1 by m2 is equal to 1 plus uv by c square whole divided by 1 minus uv by c square. Then take the one side, that is the 1 minus u1 by c square. So we get the equation number 5. After solving it, we get this velocity for one particle. Similarly, we get the second ball with the velocity u2. So 1 minus u2 square by c square. In the numerator side, we get 1 minus u square by c square, 1 minus v square by c square whole divided by 1 plus uv by c square, brackets. Divide equation 6 by 5. So we get this equation, just we are dividing it. So we get 1 minus under root of 1 minus u square by c square whole divided by 1 root of 1 minus, so bracket close. So 1 plus uv by c square, 1 minus uv by c square. From equation 7 and 4, we get the m1 by m2, that is 1 minus under root of 1 minus u square by c square whole divided by 1 minus under root of 1 minus u1 square by c square. Just taking this simplified, that is m1 under root of 1 minus u1 square by c square is equal to m2 into under root of 1 minus u2 square by c square. This left hand side and right hand side of the equation 8 are independent of each other. The above result can be true only if each is a constant, if each term is a constant. So therefore we get m1 under root of 1 minus u1 square by c square is equal to m2 under root of 1 minus u2 square by c square is equal to m0. The constant denoted by m0 is called the rest mass of the body and corresponds to zero velocity. Thus we can write m1 is equal to m0 divided by under root of 1 minus u1 square by c square. In general, if m denotes the mass of a body when it is moving with a constant velocity v, then we can write m1 is equal to, or simply we can write m is equal to m0 divided by under root of 1 minus v square by c square. This is the formula for the relativistic mass. If v tends to 0, then m tends to infinity. That is, an object traveling at the speed of light would have infinite mass. Thus, equation shows no material particle can be velocity equal to or greater than the velocity of light. So this equation 9 gives the mass increases with increase in velocity. When v by c tends far less than 1, the difference between m and m0 becomes insignificant. So this is the variation of mass with velocity. So I hope you understand the velocity of addition. It is simply the mathematical steps are there. So this m1 m is equal to m0 divided by under root of 1 minus v square by c square is relativity of the mass. So I hope you understand all the steps. So thank you very much for watching this video. Thank you.